Alright, hey guys, we're going to be continuing on with probability, and we're going to be talking about making predictions in probability. So, how do you know when we're trying to predict something? Well, it's when you read a problem and it gives you a scenario, and then asks you to make a prediction. So it says this happens, now what's the probability of this happening if there's that many? But it asks you to make a prediction based upon that scenario, so you need to make a WGU. Just like with everything else we've been doing this year, make a WGU. My little hint for you is your original probability, what they give you at first, that's going to go in your G column. Alright, so examples. We got, it looks like 6 examples today, so we're going to try and fly through them. So, today, the experimental probability of her making a bullseye when throwing darts is 2/10 or 20%. Out of 75 throws, about how many bullseyes could she predict she would make? So, Danae found that the experimental probability was 2/10. So that's my original probability. That's what they gave me at first. Okay, does that make sense? Then it says, out of 75 throws, so if I throw it 10 times, I make it 2. But I want to know if I throw it 75 times, how many bullseyes am I going to make? So like I said, you make a WGU. I'm going to do total throws. And then I'm going to abbreviate BE for bullseye. Alright. Your given probability is 2/10. Right? Because that's what they gave us. Unknown. It wants to know how many bullseyes. So do you know? No, so this is your unknown. What'd you do if you had a total of 75 throws? So your 75 would go here. Now, how do you solve this? You cross multiply. 10x is equal to 75 times 2 is what? Get 150. Divide by your coefficient to... Hopefully you finished my sentence and said isolate your variable. Cross off 2 zeros. X is equal to 15 bullseyes. Now, Ms. Hitchcock, there is 20%. Why did you not use that 20%? Well, guess what? You could have used 20% if they gave you a percentage. When you see a percentage, what should you think? Part over whole equals percent over 100. Well, my percent was 20 over 100, and I wanted to know out of a total or a whole of 75, how many would I make? So it should have ended up looking like this. Alright, well, not letting me zoom in, sorry y'all. If you cross multiply 100x is equal to, you don't have to write this, I'm just showing you, 75 times 20 is 1500, divide by 100, divide by 100, 1500 divided by 100, can you see that? Is equal to 15. So 15 over here, 15 over here, you get the same answer. Alright, the next one, you roll a standard number cube, that's just a dice, 150 times. Predict how many times you'll roll a 3 or a 4. Well, first of all, you need to find your original probability. Your original probability is not given to you, so you have to find it. Well, I want to know if I just roll a dice once, what's the probability of me rolling a 3 or a 4? Well, there's 6 total options, right? And how many are 3 and 4? Hopefully you said 2. So look, now we have our original probability. Now, we're asking to predict, tells us predicting, so I know I should make a WGU. So I'm just going to throw this fraction into a WGU. 6 is my total opportunities. 2 is my 3/4, rolling a 3 or a 4. Alright, it's asking me if I roll 150 times. Well, so I put 150 here. And I'm going to say, how many times am I going to roll a 3 or a 4? You can cross multiply and cross multiply, because we're not given a percent this time. That's why we're using a WGU. 6 times x is 6x. 2 times 150 is 300. divide by 6, divide by 6. X is equal to 300 divided by 6 is 50 times. Alright, I'm about to move on to the next one, but if you're still paying attention, I want you to put this answer in number 1. In the Google Doc, it's gonna say question number 1, and I want you to put 50 times in there. Alright, next we're going to be talking about qualitative prediction. This helps you decide which situation is more likely in general. Alright, so a doctor's office records data and concludes that on average 11% of patients call to reschedule their appointments per week. The office manager predicts 23 appointments will be rescheduled out of a total of 240 during the next week. Is this prediction reasonable? Well, you have to understand what the question is saying. It's saying 11% is going to be 23. And if I have a total of 240, if I find 11% of 240, I should get the number 23. Okay? Basically, what you need to understand is you have a percentage, right? So, P over W, percent over 100. Keep your 100 because that's your gimme, right? Your percent is 11. What was your total? Hopefully you said 240. Alright, now think about it. 11% of 240, I should, if it's reasonable, I should get 23, right? So let's put an X here and let's see what we get. We're going to cross multiply. 100x is equal to, it's 240 times 11. Pause it and do it yourself. Hopefully you got 2,640. Now we're going to divide that by 100. We're going to divide this side by 100. Remember, dividing by 100 is the same thing as moving your decimal 2 places over. So, x is equal to 26.4. But we know we can't have 0.4 of a person, remember, because we're talking about how many appointments, or I guess you can't have 0.4 of an appointment. So, we're going to round down to 26. So, is 23 a reasonable prediction? Okay, it's in the same ballpark, but 23 is a little low. Okay, what I mean is they predicted 23, but they actually had 26 cancel. So they were a little bit low. Alright, the last problem on this page. Herschel pulls a sock out of his drawer without looking and puts it on. The sock is black. I feel like that's going to be important. There are 7 black socks, 8 white socks, and 5 striped socks left in the drawer. He pulls out a second sock without looking. Is it likely he'll be wearing matching socks to school? Alright, well, first my question for you is, how many socks are there total? Well, 7 plus 8 is 15, plus 5 is 20. So there's 20 socks total. The first one he pulls out is black, right? So how many options do I have that are black? Well, these are all the socks that are left in the drawer, and I see that there's 7 black socks left. So the probability of him matching is 7/20. Sorry, 7/20. The probability of him matching socks is 7/20. What's the probability of him not matching? Well, I still have 20 socks total. If he's not going to be matching, I mean, you have to do the 1 minus 20, or what plus 7 is going to give you 20? Sorry, I want you to do what plus 7 is going to give you 20? Well, 13. Or you could say the socks that aren't black are white and striped, and there's 8 plus 5 is 13. So, is it more likely he's going to be matching or not matching? Not matching, because not matching is a bigger number. This is a bigger fraction, a bigger percentage of the total. So, for question number 2, I want you to put NM. NM, I just mean not matching. Okay? And that's, again, in the Google Doc. You're going to put that in the Google Doc. Alright, 2 more. Yay! Number 3. All 2,000 customers at a gym are randomly assigned a 3-digit security code. That they use, it's supposed to be use, not sue, that they use to access their online accounts. The codes are made up of the digits 0 through 4, and the digits can be repeated. Is it likely that fewer than 10 customers are issued the code 103? Alright, so we need to find an original probability. What is our original probability? Well, I see that we have a 3-digit security code. Alright, so I think, well, that's important, so I'm going to do my 3 digits here. Okay, so this digit can be 0 through 4, this digit can be 0 through 4, and this digit can be 0 through 4 because they can be repeated. That was the important part. They can be repeated. So how many options do you have here? Well, you could do 0, 1, 2, 3, 4. So you have 5 options here, 5 options here, 5 options here. This is just like making a tree diagram. Do 5, 5, 5, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. The cheat way is just to multiply all your options together. 5 times 5 is 25, times another 5 is 125. Alright, so there's 125 possibilities, and I want to know how many options can you get 103? You can only get 103 one way, right? Because you can only have a 1 here, a 0 here, and a 3 here. You can't get 103 any other way. So the probability of me getting a 103 as my code is 1 chance out of a total of 125. Alright? Now it says all of 2,000 customers at the gym are assigned this. Well, it's asking you to predict how many of those customers are going to have this code 103. So we're predicting, so we're going to make a WGU. Sorry, I'm overlapping. Okay, this is code 103. This is total. Alright, all 2,000 customers. So is 2,000 going to go in my numerator or my denominator? Denominator, because a total of 2,000 people are getting this code, right? Okay, so this is x. So cross multiply, 125x is equal to 2,000. Divide by your coefficient, divide by your coefficient. Tell me what you get for x. Should have got x is equal to 16. Alright? So that means that if this is true, which it is true, and they have 2,000 customers, 16 people are going to get the code 103. Alright? So is it likely that fewer than 10 of the customers are issued the code? Is it likely? No. No, because why? Because we calculated that 16 people are going to get the code. Because 16 people will get code. Alright, last one. Yay! By the way, put 16 in question number 3. Alrighty. It's going to say Q3. I want you to put 16. Last one. An online poll for a movie site shows it's polling for a new movie. If a newspaper surveys 150 people leaving the movie, how many can it predict will like the movie based on the online poll? Okay, so I see that they like it, so I'm looking at the yes section, right? And I see a what? Percentage. What are you going to do? Part over whole equals percent over 100. So my percent is 72 over 100. How many people did we survey in all? Or how many people told us they liked the movie? We don't know how many people told us they liked the movie, but we do know we surveyed a total of 150 people, right? Alright, I want you to set up the equation for me. I want you to be blank x is equal to blank. Pause the video and do that. Alright, so we got 10,800 is equal to 100x. Divide by your coefficient to isolate your variable. X is equal to 108. Alright, so we know that 108 people, I'm going to do a check mark, like the movie. Alright, is the movie site's claim accurate if the newspaper has 104 people they say that they like the movie? Alright, so is 108 people accurate? Well, yeah, I mean 104 is fairly close to 108. It's not exact, but it is accurate, not exact. Alright, the last thing I want you to do is I want you to go in and put 108 as question number 4. The number 108 as question number 4. Okay, you guys have a great day. Enjoy the rest of your evening, and we will see you guys tomorrow.